This is section 8.3, Logarithms and Logarithmic Equations. Our objective today is I can evaluate logarithmic expressions. With our key concept box, we can see that this is pretty much telling us how we can change a log into an exponential equation and an exponential equation into a logarithmic equation. And this, even though it's not our objective today, it is a very valuable part of being able to evaluate logarithmic expressions. So the definition of logarithms can be used to express logarithms in exponential form. And we have a good example up at the top in the key concept box. If we see here, we have a log, and then we are able to use our definition and convert it into an exponential equation. And we can do that by just knowing the order. So let's go ahead and take a look at our examples. In these examples, we have log equations and we're putting them in exponential form. So the way that we're going to do that, we're always going to start with our small number. So in this case, our small number is our 3. So we're going to write 3 first, and then we're going to use our outside number, which in this case is 2. And that's going to become our exponent. And the only number that's left is 9. So 3 squared equals 9 is our exponential form. We can always check this by asking ourselves, does 3 squared actually equal 9? And yes, it does. So we know that that's going to be our final answer. And this is just writing it in exponential form. On the second one, we're going to follow the same pattern. We're going to take our small number, which is 10. We're going to raise it to the power of what's on the outside, which is -2. And it's going to equal the inside value, which is 1 over 100. We can check this by asking ourselves, does 10 to the power of -2 equal 1 over 100? Yes, it does. So we know that that is written correctly. So we can also use the definition of logarithms to write exponential equations in logarithmic form. So this is just working backwards. Okay, so this is really just a pattern. So we have on example 2a, we have 5 to the third equals 125, and we're going to write it in logarithmic form. The first thing you're going to want to do every time you're writing in logarithmic form is to go ahead and write log. Okay? Now we're going to do the exact opposite. Our first number, we remember from the last example, we got that from that baby number. So we're going to go ahead and write that small number down here. And remember, the exponent is what we grabbed from the outside. So we want to go ahead and put that exponent on the outside. And then remember, we grabbed that last number from the inside. So the 125 is going to go on the inside. And that's going to be our final answer. We'll do the same thing in the second example. We're going to go ahead and write our log because they want it in logarithmic form. Our first number is going to become our little tiny number. And then remember that exponent is what we grabbed from the outside. So we want to go ahead and put that 1/3 on the outside. And then our last number is going to go on the inside. So we have log 27 of 3 equals 1/3, and that's going to be our final answer here. Now that we are able to use our definitions, we can actually evaluate logarithmic expressions. So we have several examples we're going to go over. We have log 3 of 243, and we don't know what that equals, and we want to solve that. So we're going to go ahead and we're going to put that equal to x. So now we can go ahead and rewrite this using what we just did, and we can say, okay, so 3 to the power of x equals 243. And now what's really nice is we can use what you guys have already learned in 8.1, 8.2 to be able to solve this. So we want to rewrite one of the sides so that they have the exact same base. In this case, we can rewrite the right-hand side. So we're going to leave 3 to the power of x, and we're going to rewrite 243 as 3 to the 5th power. Now remember, you might have to try a few different things before you figure out, okay, what does give me 243? So now that our bases are the same and there's not any more work to be done, we can cancel out our bases, And we're just left with x equals 5, which is our final answer. In the second example, we're going to follow the same procedure. So we're going to have 10 to the power of x, because we know that this equation, we don't know what it equals, so we set it equal to x. And then we have 10 to the power of x equals 1,000. And I know that 10 to the power of 3 equals 1,000, so I can go ahead and replace the 1,000 with 10 to the power of 3. And now that my bases are the same, I'm going to cancel those out, and my final answer is going to be x equals 3. In the next example, we'll go ahead and set it equal to x again, because we don't know what it equals. And then we can go ahead and write this as 16 to the power of x equals 4. And again, we're just using that logarithmic to exponential form to be able to do that. Now I need to change one of these so that they're equal. Now in this case, I'm going to go ahead and change my 16 to 4 squared. Okay, I still have the x there that I got to keep. So now I know that I have to distribute the 2 to the x. So I'm going to have 4 to the power of 2x equals 4. And since the 4 on the right-hand side doesn't have an exponent, I'm just going to give him a 1. And so now that my bases are the same and there's no more work to be done, I can cancel those out. And I'm going to be left with 2x equals 1. And to get that x by itself, I'm going to divide by 2. So our final answer is going to be x equals 1/2. In the next example, same thing. We'll set it equal to x. We'll rewrite this as 3 to the power of x equals 81. And I can rewrite the 81 as 3 to the power of 4. So now that my bases are the same and there's no more work to be done, I can cancel out my 3's, and x equals 4 for my final answer. On the last example, same type of procedure. We'll set it equal to x, and now we have 1/2 to the power of x equals 256. Now this is like the example in 8.1, 8.2 that I added in. It wasn't in your notes, but I added it in on the video notes. So we're going to need to rewrite this so that it isn't a fraction. So the way that I do that, I can bring that 2 up and give it a negative exponent. So I have 2 to the power of -1. I still have my x, and that equals 256. So now I'm just looking for what can I actually rewrite. So I know I can rewrite 256 as 2 to the power of 8. So I have 2 to the power of negative x, because I can distribute the -1 to the x and get negative x, equals 2 to the power of 8. Now that my bases are the same, I can go ahead and cancel them. And negative x equals 8, but I don't want negative x, so I'm going to divide both sides by -1, and x equals -8.